Everyone says Rust is blazingly fast because of zero cost abstractions. But I have a secret. Async Rust is not a zero cost abstraction. If you take a CPU bound task and wrap it in async, it will run slower. If you read a file from a fast SSD using TokyoFS, it will likely be slower than standard library FS. Today we are looking at the three taxes of async Rust: state machines, polling, and context switching. So you know exactly when to ditch the runtime and go back to sync. To see this in action, let's look at this example where we have two functions. Uh, First is a synchronous function and second one is asynchronous function. And in our main function, we are printing the consume memory of both of the functions. So in sync Rust, your functions variable live on the stack. In async, they live in async they have to live inside a state machine. So let's look at the size cost. So now we're going to run our program and see uh, which one takes much memory compared to other. So let's run our program. So as you can see, sync function only took 0, whereas asynchronous function took around 1027 kilobytes. So the async version is physically larger. Every variable you hold across an dot await point must dot await point must be packed into an enum. This uses more memory and puts more pressure on your CPU cache. If you have thousands of this, the zero cost abstraction starts looking pretty expensive. And for those of you who don't know what Tokyo Task Yield Now function is, Yield Now is particularly useful in CPU bound async code that runs for a significant amount of time without any natural dot await. By inserting yield now.await, the task ensures it does not hog the CPU and allows other tasks to make progress, improving overall runtime responsiveness. Now let's look at this example where this one that surprises most people. Uh, in this, surely async IO is faster, right? But not always. If you have modern NVMe drive, it is also fast that the overhead of a runtime actually slows it down. So first look at this what we are doing. So we have some large video file and we are appending its data inside a vector buffer by using two methods. First one is standard library fs file opening method, and second is Tokyo fs file opening, and we are awaiting that. And we are appending its buffer result to an vector, and we are again awaiting it. So in version, there's a in sync version, the OS just hands data to your thread. In async version, Tokyo has to register the file descriptor, wait for the event loop, wait the task, hold the future. So if your IO is extremely low latency, like a local SSD, all that management is just extra CPU work that results in lower through output. Most async runtimes use work stealing. If worker thread 1 is busy, worker thread 2 steals your task, but your CPU hates this. When a task moves from core A to core B, it leaves a hot cache behind. Every variable it needs now has to be fetched from slow RAM again. In a sync app, you can pin threads to cores to keep them fast. In general purpose async runtime, your tasks are jumping around like popcorn, constantly killing your CPU L1 cache performance. So am I saying stop using async? No, I'm saying understand the goal. Use sync if you want the lowest latency for a single task, like CLI tools, image processing, and mathematical computation, so on. And Use async if you want highest through output for 10K tasks. Web servers for web servers, proxy servers, chat apps. Async is not about making one task faster. It's about making sure 10,000 tasks don't crash your system. If you only have one task, the tax is not worth it. The best Rust developers know when not to use a feature. So yeah, that's it for this video. Thank you.